All right, well, good morning, everyone, and welcome to our presentation on Senate Bill 712, the Water Quality Performance Standards. I am Melissa Lawrence, and I am a Bureau Chief here at the Water Management District. And today I am joined by Jess Markle, who is also a Bureau Chief. I am the Bureau Chief over the West Coast and the Orlando offices, and Jess is the Bureau Chief over the Okeechobee and the West Palm offices. Joining us today for our presentation, we're going to have Jill Creech, our Division Director, and Patty Tarian, who is a lead engineer out of our Orlando office. The format for today is we're going to begin with a presentation on sections 8 and 9 of the Environmental Resource Permit Applicants Handbook Volume 1, and changes also to Volume 2 of the Applicants Handbook. Jess Markle is going to be going over a presentation on that. We're going to take a brief break while we change presenters, and then Patty Tarian is going to be going over a couple of stormwater design examples. After our presentations, we're going to be doing some question and answers. We're going to ask that everyone holds their questions until the end of the presentations. We're expecting a lot of attendees today, so we're going to wait for the end of our presentations, and we're going to do those questions at the end. If you have any questions or comments, the way those work in Zoom is you can either use your raise hand feature, or if you're on a phone, you can use *9 to raise your hand, and then *6 will mute or unmute your phone number. And then the presentation will also be available after the Zoom for anyone who would like a copy of it. So with that, I'm going to go ahead and turn it over to Jess so he can get started.
Well, good morning. Now that we've had that introduction, we'll go ahead and jump right into what is bringing us here today, which is the change in the water quality performance standards, beginning with the changes that we had in ERP Applicants Handbook Volume 1. A little bit of history. In 2020, Governor DeSantis signed the Clean Waterway Act into law. Among other things, it directed the DEP and the water management districts to begin rulemaking, which was done throughout the years between 2020 and 2023, at which point the rule was adopted, sent to the House and Senate for ratification because the estimated regulatory costs exceeded $1 million over 5 years. Neither the House or the Senate took it up in the 2023 session, but did take it up in 2024, where it was ratified, and then the governor signed it into law. At which point, on June 28th of 2024, it became effective. Although it had a number of grandfathering provisions, those provisions can be seen at the DEP's ERP Stormwater Resource Center. There is a very informative grandfathering flow chart that will help you walk through at what point in time your project is going to have to meet these standards. And for most projects, that time is coming up very, very soon, a little less than 60 days at the end of December. At which point, in order to remain under the volumetric water quality rules, your application must be deemed complete. In short, what that means is you will not be receiving any further RAIs. It does not mean your permit has to be issued, just that you have submitted and there will not be any further comments of any variety. We do ask in these next 2 months that you prioritize responding to RAIs for projects that you know are not grandfathered, that will have to meet this new standard after December 28th of 2025. There is a performance criteria flow chart, a link to which is in this presentation, which again, as Melissa said, will be made available after we conclude. That will walk you through all these rules that I am going to go over to give you an idea of what applies to your project. I'm going to apologize in advance. These slides are very text intensive, not a lot of pictures for us to use, but we'll move through it, I think, at a reasonable pace. So the minimum standard for all sites, regardless of where you are in the state, is as follows: an 80% reduction in total phosphorus and a 55% reduction in total nitrogen from your project prior to any introduction of best management practices. The other standard that has to be evaluated is net improvement. So a pre versus post, in which your post-development nutrient load is less than your pre. And then of those two, it is the most stringent, the most protective standard that applies. Pre-development is defined in Volume 1, the land use, land cover, or other site conditions that are in existence at the time you make your application. So a site that was farmed 20 years ago but has not been in agricultural for a period of time is not your pre-development condition. It is where it is the day that you make the application to us. The next criteria as we move through has to do with projects that are upstream of an outstanding Florida water, in which case the percentage reduction changes to a 90% reduction in phosphorus and an 80% reduction in nitrogen. And again, net improvement. So you're going to see a common theme that net improvement is a backstop criteria that has to be met. From there, the next most stringent set of criteria has to do with whether or not your project is in an area that it has an impaired water in it. If it does, but you're not upstream of an OFW, then your standard is an 80% reduction in phosphorus and nitrogen. If you are upstream of an OFW and within an area that has an impairment, that standard elevates to 95% reduction for both phosphorus and nitrogen. Again, the backstop of net improvement. And then you also must demonstrate that you're showing an improvement in whatever pollutants are actually causing the impairment. Not every impairment has to do with phosphorus and nitrogen. Moving forward, we do have a standard for impaired waters that have an adopted TMDL or BMAP. And that is that you must meet the level of treatment for a basin-specific design and criteria that's prescribed in such a TMDL. Do you have to describe a net improvement in pollutants? Now, what's important to note is that basic specific design and performance criteria is not the same as the general allocation for a TMDL. My example is the Lake Okeechobee watershed, which has an adopted TMDL of 105 metric tons per year, but your project would need to have a basin-specific criteria defined by DEP. And at this point in time, there are not any. So this rule, this performance criteria is somewhat of a placeholder in anticipation of a time when there may be a more specific TMDL within smaller areas of the state. We do have criteria for redevelopment, and redevelopment is defined. It is any existing commercial, industrial, institutional, roadway, or residential land use. So in short, it is not agriculture. It cannot have a permit over it. Your new impervious area has to be less or equal to whatever impervious area is there today. And your change in land use has to result in a lower event mean concentration value. You can opt to meet sections 8.3.2 and 8.3.4, the ones I've just gone through, or you have these more specific criteria of a percentage reduction in phosphorus and nitrogen with an elevated standard for discharge to an OFW and a net improvement of pollutants causing an impairment if you're within an impaired body. There is an exemption. That exemption will be processed under what we commonly call the de minimis exemption in Florida statute. There are criteria for that. The project has to be less than an acre. You cannot be discharging or within an impaired water body, nor an OFW. Your impervious area and your pollutant loading has to be reduced from what it is today. And then you do need to give us supporting information about why the site has to be viewed as exempt. Things like percolation rates, if you have particularly poor percolation rates, or a very high seasonal high water table or mean high tide for receiving waters, or there are other area limitations that do not make meeting the more strict standard possible for your site. Now with that, I'm going to very quickly transition into section 9, which is the actual calculation portion of Handbook 1. And the first thing, to use the tired Seinfeld joke, is location, location, location. Everything that you're going to be subject to is going to start with where you are located in the state. And to determine that, we are using hydraulic unit codes 12 within the USGS system. There is a very nice GIS utility that DEP has made available. It does break the state down into those HUC 12s. It also has coverages for imported waters and OFWs. So you're able to find your site, and from that information, you can figure out, are you upstream or downstream of an impaired water? Are you within a HUC that has an impaired water? Are you upstream and downstream of an outstanding Florida water? And from there, with that performance chart or the text in the rule, you can then triangulate which of the criteria apply to your project. Now, to calculate that nutrient load, you're going to do a few things. The first thing we recommend is you determine your pre and post development loads. The methodology that we are applying is the foundational material is the 2007 DEP report that Dr. Harvey Harper authored. And a lot of those things, a lot of the concepts in that have been extracted and put into this rule. That method is very much runoff based. So you need to know what rainfall you have. And from that, you'll look into Appendix M, and we'll show some screenshots of what that looks like. And then the design examples will give you a more clear idea of how to apply that information. You then need to define both your pre and post development land use. You need to establish what your directly connected impervious area is. That is a very important concept in this methodology. And there is a definition. There are a couple places where DCIA is defined. First, in the definition section of Volume 1, it's building, impermeable pavement, impervious surface, and it's those areas that drain directly into your conveyance system without going over some form of pervious area. There's another definition or an additional supplemental definition in section 9.2 that does talk about it being a concentrated shallow flow over a short pervious area. So it's not that you've got 6 inches of grass that an acre of parking lot drains over, and therefore it's not DCIA. You have to look more closely at that. And when you calculate that number, it is a percentage of the total project site, not simply a percentage of your impervious areas. To kind of further this idea of how much land you have to drain over to be disconnected, there is a definition of non-DCIA. So of course, all pervious areas are not directly connected impervious, but any portion of an impervious area that flows over at least 10 feet of an undisturbed green space that has a hydraulic soil group of A or B will be considered disconnected. If you flow over at least 20 feet for other soil types, so your C and D soils, but you've got sufficient infiltration to show that a 3-year, 1-hour runoff volume will go to ground before it makes its way down the hill, so to speak, then you can also claim that area as being disconnected impervious area. You will absolutely need to calculate a curve number for these non-DCIA areas. And from that, using information in the handbook, you'll be able to come up with a runoff coefficient. It is that runoff coefficient times the area of the project times that rainfall, which is an average annual rainfall amount that comes up with your runoff volume. And then you also use your DCIA percentage and your curve number along with where in the state you are to come up with your event mean concentration. And we do have prescribed amounts for those EMCs that are in the rule. You can be more conservative, you can be more protective, meaning on the pre-development side, if you want to use an EMC that is actually lower than what Volume 1 has, you can do that. Conversely, on the post-development side, if you want to use an EMC that's larger than what's in the table, you can do that as well. The factor of safety, you are not obligated to. The minimum requirement is what you see in this table 9.2 of Volume 1. From there, you're going to determine your load reductions. You're going to look at your net improvement. So simply take your post-development load and subtract it from your pre-development, or vice versa, pardon me, pre-development load, subtract it from your post-development. Whatever's left over is the amount of load that you have to treat and bring down. Your percent reduction is simply those percentages that I rattled off and looking at the various sections of section 8.3 and then multiplying that by your post-development load. And again, you have to select the greatest reduction. It is possible that one method, net improvement, might be the governing standard for phosphorus, while a percent reduction would be for nitrogen. So this table is a very crude demonstration of that. And this, very, very abstract example, your net improvement says that you have to address 100 pounds of phosphorus and 150 pounds of nitrogen, whereas your percent reduction says it's 120 pounds of phosphorus that has to be removed and only 80 pounds of nitrogen. So your requirement for your project would be 120 pounds of phosphorus based on the percent reduction, but 150 pounds of nitrogen removed based on your net improvement. This rainfall data that I addressed earlier, it is exhibited quite nicely in these two graphics. The state of Florida has been divided into 5 separate zones. And from that, an isopleth map of the entire state has been generated to give you an idea of what the annual rainfall is. You do need both pieces of information. Runoff coefficients and event mean, or rather reduction percentages for BMPs are tied to where in the state you are. And obviously rainfall is also a spatial characteristic that we have to note. And for South Florida, please note that our rainfalls vary from the high 40 inches per year to just over 60 inches per year. So you've got a very wide amount of runoff to deal with depending where you are. So a project in the Fort Myers area is going to have very different characteristics from a runoff perspective than a project in Orlando, even if they are mirror images of one another otherwise. So moving into 9.5, we start talking about the actual best management practices for stormwater treatment. In Appendix O, there is a table. That table provides to you the percent reductions for various common BMPs. And if they don't have a set percentage, there is a methodology that is used to calculate those. I'm going to touch on maybe some of the more common ones, but there are others that are in that table that are not addressed in the presentation. So for your wet detention, your common lake, big factor you need to understand is what is your permanent pool volume? What is the volume of water that is always held in the lake? So that's from the bottom of the lake to the seasonal high water table / control elevation. We're all fairly familiar with doing a stage storage curve for our site. That usually starts at control and goes up to some higher elevation. You'll now need to start calculating the stage storage from the bottom of your pond all the way up to whatever high elevation. With that permanent pool volume and the runoff volume from the site, you're going to determine what your residence time in that permanent pool is. Very simple calculation, volume divided by the runoff rate, if you will, converted to days. There is a limitation. Despite what this calculation that I've got on the screen would yield, you cannot claim anything more than 200 days of residence time. For retention, different kind of BMP, but still going to be something we see very, very commonly. You do need to calculate the volume in your retention area or areas if they are interconnected at the same elevation. Simple calc from the bottom to the top of bank. Your retention depth then becomes whatever runoff volume you have from your site divided by the area contributing that runoff. And that gives you how many inches over the site of treatment you will be providing. There's also a ceiling here of 4 inches. And inherent in this, and very, very important, is you must demonstrate that that volume will recover in 3 days or less. Within a wet detention system, for those of you that are going to seek to maximize how much a lake or a pond can do, you might look at using a littoral zone. This is one of those BMPs in which there is a set percentage reduction, and that is set at 10%. You do need to provide a planting plan. We need to see that what you're going to plant in that littoral zone. And one of the biggest things we want to see is survivability. We want to make sure that these are plants that can handle water levels rising and falling. that it's not going to become a denuded bank, in which case you don't see any uptake. If you're using littoral zone, to get that 10% reduction, at least 20% of the lake area needs to be planted. And then you will need to provide a monitoring and perpetual maintenance plan for that, which includes the harvesting of the biomass. So as the vegetation dies, it needs to be removed. And in some cases, you'll have to replant in order to keep that 10% reduction. Another BMP that we see being kind of layered in the lake environment will be stormwater harvesting, irrigating out of the pond. We need to know what your irrigated acreage is. We need to know what volume you're going to be able to store above the permanent pool volume that will be used for irrigation. So from your control elevation or seasonal high to wherever you might set the invert of a bleeder or a weir that would allow discharge. You'll need to calculate what your irrigation rate is. What is your volume of irrigation divided by that irrigated acreage? And that needs to be the same as any water use allocation that you may be receiving. You cannot tell us that you're going to pull out more irrigation for the purpose of water quality treatment than you can do for the purpose of irrigating by permit. And for this reason, this makes the concurrency, the linkage between the ERP and the water use permit very, very important. We have to see that these two activities are aligned with one another through the permitting process. Another very common BMP, at least here in the South Florida Water Management District, is exfiltration trench. Nothing new and different about exfiltration trench. You'll still be defining all the same physical characteristics that you have: the length, the width, the saturated and unsaturated trench depths, the hydraulic conductivity, and the driving head, and then using whichever of the two exfiltration equations that apply to your project based on the width and whether or not your saturated trench depth is equal to or greater than your unsaturated trench depth. Once you have that volume, you'll divide it by the area, the runoff area. And again, this is considered a retention BMP, so you're limited to 4 inches. One thing to take away is that with the exception of some of these more specific BMPs, such as stormwater irrigation, such as littoral zones, the various structural baffle box kinds of things, you have two basic macro BMPs. You have wet detention and you have retention. For the most part, everything is going to fall in one of those two categories, which becomes important as you go through calculating your efficiencies for your BMPs and which set of equations or tables governs those performances. If you have offsite water coming into your system, those have to be accounted for in your water quality requirements. So whatever load is coming from that offsite area is going to enter into your water management system. That now becomes an input, and you have to take into account that that is a pre-existing load, and therefore whatever reduction has to be met must be based on that load coming in, as well as the load generated by your project. Now with that, I'm going to pause ever so briefly to get a drink of water, and then we'll move into the changes that have occurred in Volume 2. All right, so part of the rulemaking, we had to make conforming changes to Volume 2 to account for what was happening in Volume 1. The biggest one is that the vast majority of the water quality criteria that you all are used to seeing in Volume 2 were deleted, superseded, and moved into Volume 1. There were some things that remained, and a lot of it having to do with some of our more bespoke criteria here in South Florida. One of those was dry pretreatment. That is still in evidence in the rules. It is just looked at differently now. Instead of a number of inches over the site, it is a percentage of the load reduction. So if you have a commercial and industrial master system that you are proposing, then 20% of the load reduction that is calculated and will be the standard based on all those criteria I've already gone over, that will have to occur in a retention BMP. You can, just as before, have the individual lots provide any balance, but we do need to see at least 20% of that load reduction in the master system through a retention. If you're not doing a master plan, but just doing a commercial industrial site, likewise, 20% of that load reduction. So what I mean by that is if you've calculated that you have to reduce the load by 100 pounds, 20 pounds of that has to be taken out of the system by virtue of a retention BMP. We do have areas that we're more protective of because of their very nature. So if you have a project that is more than 40% impervious and directly discharging to any one of these protected water bodies on this list here, which is also in rule, then you also have to provide that 20% reduction. So there are some very, very specific areas, mitigation bank lands, outstanding Florida waters, public water supply, well field, cones, and depression. If you are for some reason able to discharge into one of those areas because it is a potable water supply, we need to see that 20% retention reduction being applied in your design. One of the last things to touch on here is we do still have wet detention design and performance criteria. Ponds have to be a half acre. They can't be less than 100 foot in width on average. The one I'm calling out here is very, very specific to the water quality performance standards. And that, again, is kind of a regurgitation of the littoral zone concept. If you want to use a littoral zone for any kind of load reduction, it has to be 20% of the area of your lake. So I've moved through that much quicker than I think we anticipated. These concepts will be teased out more in the design examples. Melissa, we may be ahead of schedule, so I don't know if we want to go ahead and take the break or go ahead and charge right in.
Yeah, we can take a short break just to let Patty transition to taking control of the screen.
Yeah, I'll just need a moment.
Thanks, Patty. And Patty, if you can just put the disclaimer back up just to give everyone just a chance to read it. We're just providing these design examples for reference purposes only. So we're just trying to give these to everyone just to help everyone and give them some references. So we'll just give you a minute to read that before we jump in.
Okay, well, hopefully everybody has read that. I will say that, so just to reintroduce myself, I'm Patty Therian, lead engineer here in the Orlando Service Center. We've got two design examples for you today. One is for a multifamily site. The other is for a roadway widening. The multifamily site, we are assuming that the existing condition is Marl Prairie, and that the proposed condition obviously is multifamily. As Jess said earlier, it's all about location. So when we look at this site, one thing we're assuming is we wanted to use pervious pavement as your initial BMP and dry retention ponds as the secondary BMP. And as we move through this, you'll see why some of these calculations are so important. Starting with location. So this, we picked a site in Orange County at random. I'm going to pull up. This is the FDEP HUC 12, HUC 12 boundaries and impaired waters OFW's website. You do have the opportunity to add layers, but we're just going to go with the standard how it comes up when you see it through the site. As you click on you zoom into your site area, what you're going to see is this will come up as the whole state. I've already zoomed into the HUC 12 that are in which our site exists. If you click on that HUC 12, you'll see it comes up Shingle Creek. Scroll down a little bit, the HUC 12, that 12-digit code. One thing that may come up is it will list, okay, of course it goes slow now. It may come up where it lists if you have multiple options, multiple water bodies coming up, and it will list the impairment. The site will, you can click forward and it will give you the impairment as well. Let's see if I can zoom in a little bit and get this to come up. If not, we'll just move forward. Okay, yeah, the impairment is not coming up right now. Site is not cooperating with me. Okay, back to that. So we have a multifamily site. In this case, we are assuming, yes, we have a development within an impaired basin that is impaired for nutrients, macrophytes. In this case, we are assuming that the impaired watershed is not downstream, or the impaired water body, and there is no OFW downstream. Our site is 10 acres in size, and the proposed land use, we will have 5.9 acres of impervious area, 3 acres of rooftop, 2.9 acres of roads and parking. We will have pervious area of 2.6 acres, dry retention area of 1.5 acres. And our water table, seasonal high water table is at 88. The receiving water body, the water elevation is 87.5. So first, we look at what is required. Since we are in a, I'm going to go over to flip over to that flow chart that Jeff just mentioned. This is also on that DEP website. The project is not for redevelopment. So it is located within a HUC 12 or adjacent to a HUC 12 containing an impaired water. That's that first block at the top of the flow chart. Is it upstream of that impaired water? So in this case, we're going to look at no, we're going to follow that, determine the TN and TP reduction required based on site location. In this case, we're assuming it does not contain an impaired water body or OFW. So provide a 55% TN and 80% TP reduction from the post-development load before treatment. Now, we also are going to have to do that pre and post-development, or that pre-development loading and then the post-development loading before treatment to determine which reduction is more stringent, pre-post or the percentage reduction. So switch back to this. Going through these calculations. Meteorological rainfall zone 2. In this case, we selected 50 inches a year. I will go back to the SWIRP manual and go back to Appendix M. One thing we will be looking at is this isoploth map and saying, did you select the right rainfall depth? You can see there's really not a 50-inch in Orange County. There's a 51-inch, there's a 52-inch, but there's not really a 50-inch, but this is for demonstration purposes. So you're going to need to look at that and make sure you've selected the right rainfall depth. Marl Prairie, the event mean concentrations, you want table 9.2 in volume 1. These are the EMC values for phosphorus and nitrogen off of table 9.2. The hydrologic soil groups is CD. Please go back and check TR 55 and also the National Engineering Handbook, Chapter 7, for dual hydrologic soil groups. Because if you have a dual hydrologic soil group and your seasonal high water table is less than 2 feet from the surface, you should use the undrained condition or the second condition, so a D soil in this case. We have obviously no impervious area in the pre-development, and so our DCIA in the pre-development is 0. And this 89 is consistent with a type D soil. So standard curve number, weighted curve number calculation. The next thing you're going to do is look at your runoff coefficient. And this runoff coefficient is not your standard C value that you're used to seeing from the rational method. This is from Appendix N. So I'm going to go back to this, and this is Appendix N. We are in Zone 2. You'll look at your non-directly connected impervious area percentage across the top. You'll look at your curve number down the side. The curve number was 89 with a 0 directly connected impervious area percentage. So you can do one of two things. You can use the higher value of 0.242 over here on the left column, or you can interpolate between 85 and 90. In our case, we interpolated and came up with a runoff coefficient of 0.226. Then you will calculate your annual runoff volume for your site. 10-acre site, 50 inches of rainfall a year, 0.226 of runoff coefficient, and then dividing by 12 to make that conversion from acre or from inches to feet. And that yields 9.417 acre feet per year of runoff volume. The next step is to calculate that annual mass loading pre-development. So the equation is 9.2. It's again, ERP Applicants Handbook Volume 2. Your annual runoff volume, your event mean concentration, and then conversion factors. So converting basically from acre feet per year to kilograms per year. So all these conversion factors come up with 1.233 times your annual runoff volume of 9.417 acre feet per year, and the event mean concentration. For phosphorus, that event mean concentration, again, 0.012, and that yields 0.139 kilograms per year of total phosphorus. Similar calculation for nitrogen, yielding 7.942 kilograms per year of nitrogen from that 10-acre site. Now, this is important. You really need to calculate that post-development loading. Same process. The EMCs from table 9.2. Here we're assuming C soils. Maybe you've raised the site up a little bit, but you're assuming C soils. But I want to point out the impervious, assuming in this case that the entire impervious area is directly connected. When you've got a multifamily site, you've got buildings surrounded by a little strip of grass, and then you've got sidewalks and pavement and everything. Chances are that you're going to get that 20 feet of undisturbed pervious area prior to it hitting the pavement and going to an inlet. It's pretty low. You might get the back side of some of the parcels or some of the areas, but you're not going to get a lot of non-directly connected impervious area. So in this case, we're assuming it's all directly connected. The pervious area CN of 74. And then again, finding that runoff coefficient from Appendix N. In this case, 74, and a DCIA of, I think it was 59%. So we're looking at about 0.48. So yeah, so 0.508 was our interpolated value. So again, calculating that runoff volume and then the annual mass loading for phosphorus and nitrogen in the same process that we did in the pre-development. You'll see a significant amount of additional phosphorus and nitrogen. So next step, that required load reduction. So we identified that it was 80% reduction for phosphorus or pre-post, whichever is greater. So we do that pre-post reduction calculation. And the pre-development was 0.139, the post-development was 13.571. That's what we calculated up here. So to have a post-development phosphorus level less than the pre-development, you need a 98.98% reduction. That's obviously greater than the 80%, so that will govern. And you're required to remove, so that again, they're 13.571 times 98.9 leads a required load removal of 13.4 kilograms per year. For nitrogen, we look at that again, 50% reduction, 55% reduction, and the pre-post going from 7.942 to 48.022 kilograms per year is 83% reduction in nitrogen. So if you compare the two, and this is why we want you to do this calculation for every single project. Don't just assume that the percent reduction is higher. Don't just assume pre-post is higher. But make sure you do that to demonstrate to us that you are providing the appropriate load reduction. In this case, it's that net improvement that's going to drive this because of the marl prairie conditions in the existing. So we're going to start off with pervious pavement. We have 8 locations of pervious pavement on our site. Assumed depth of system was 0.78 feet. And top of storage, bottom of storage, and the water table elevation, you want to have that water, the bottom of your storage above the seasonal high water table elevation. This yields a retention volume of 0.625 acre feet. That's the volume that is retained in that pervious pavement. You divide that by your 10-acre site, convert from inches to feet, or from feet to inches, you get a 75% or 0.75 inches of retention over your site. Now you need to go to Appendix O. And this is in the SWRP manual, and you will go to the dry retention, and this is, we are in zone 2, so you'll have to scroll through. There's, I think, 36 pages. Zone 2, and you're looking for, I don't know why the labeling went, but this is the second table is 1 inch of retention in zone 2 by percent DCIA. The table above is 0.75 inches of retention in zone 2. So I think we set our percent, we had a 59% DCIA, and we had a 74 on our our non-DCIA CN. So there we're looking at, if you go 55 and 75, you're looking at 73.4 is the, about there is your pollutant load removal rate. So let's go back to the calculation. The interpolated rate was 72.27. So obviously 72.27 is a lot less than this 98.98 and 83 that we need. So we're going to have to add another BMP to remove the nutrients. Before I do that, I want to point out a couple things. It is recommended that the seasonal high water table elevation be greater than 24 inches below the bottom of a pervious pavement system. For water quality credit, the seasonal high water table should be greater than 12 inches below the bottom. If you don't have a dry system, you're not really getting that retention. So let's look at the second BMP. What do we need? First, we need to figure out what treatment efficiency is required in the second BMP. There is equation 9-5 in volume 1. It is treatment. The treatment efficiency is 100%, and it's just 1 minus the efficiency of the first system and 1 minus efficiency of the second system. It's your treatment train. So our first system, we need we needed 98.9 or 0.98, 98% efficiency removal, almost 99%. The first system had a 72.27% efficiency. So put those numbers into this equation. You need the secondary system to remove 96.32% of the remaining phosphorus in the runoff that gets to that secondary system, and 40% of the remaining nitrogen that gets to that secondary system. So I'm looking at what removes 96% of phosphorus, what retention depth we're getting. So you go back to Appendix O, and if I remember, we had 2.5 inch for 75 and 55, you're looking at around, you have to basically scroll through these and say, okay, how much retention do I need? In this case, we looked at 2.5 inches of retention from Appendix O. Will get us 95.82%. Okay, so 95.82% both for phosphorus and nitrogen. Appendix O does not differentiate between nitrogen and phosphorus. It's just a nutrient removal efficiency. So dry retention pond, we had 1.5 acres, bottom area of the dry retention pond. So we look at the 2.5 inches retention depth times our total area, that yields 2.08 acre feet. Okay. Again, that 95.82, that's not enough. That doesn't get us that 96.32% we need for phosphorus. It does meet what we need for nitrogen. So we're good on nitrogen now, but we still need to do one more BMP to get that phosphorus out. In this case, we assume putting a baffle box on the pond at the outfall of the pond. So again, sliding it using that treatment train equation, the 0.9898 required removal efficiency, the 0.7227 for the pervious pavement, the 0.9582 for the retention, means we need 12% efficiency for that's to get phosphorus out. This is where we assume the baffle box. This is again in Appendix O. I'm going to go back to Appendix O. And in Appendix O, baffle boxes, gravity-based, this is that first page of separator, second generation. We assume a TP reduction of 15.5%. It's a set amount. So you're going to use that for that last bit of phosphorus. It will also, it can get, and that baffle box, by the way, that's for phosphorus. It gets 19.05% of the nitrogen out of the discharge that is getting to that baffle box. So when you look at the provided load reduction, you do again, that treatment train calculation. There's your pervious pavement, there's your dry retention, 0.9582, and there's your baffle box, 0.155. That gets you a phosphorus load reduction of 99.02%. and a total load discharged or total load reduction of total load discharge of 0.133 kilograms per year. And your nitrogen, your total load is 0.451 kilograms per year. Now, the last thing is that BMP trains, if you happen to use that instead of doing, setting up a hand calculation, doing your spreadsheets, however you do it, we want to see this type of summary table in your drainage report. So there's your pre-development annual mass loading, your post-development mass loading before treatment, your required load reduction, your target discharge load, your total provided load reduction, your post-development load with your BMPs, and your total load removed. So, and we're going to check this for, to make sure that you've got all these if you've got it in 3 decimal places, we're going to look at it for 3 decimal places. If you've got it to 2 decimal places, we'll look at it to 2. And so if you round, be careful with the rounding. So that is the water quality design for a multifamily marl prairie. I'm going to go back to that first page and take a minute, and we'll go, now let me switch over. I'll take a minute so I can switch over to my other example.
So as Patty is switching over, I just want to address a couple things really quickly. One, again, these are examples. The one she just went through, there could have been a dry retention area that did the whole thing. What we wanted to highlight is that in those situations where maybe you have design constraints and you can't get a first or second BMP to do everything, that you can continue to add BMPs to your system as the specifics of the project allow. There's also, because these are examples, a little bit of suspension of disbelief that may be necessary. The BMPs that are called out, these were not designed by district staff. They are used in a very generic way. So as you work through these examples on your own and you see places where, this could have been changed, that could have been added, absolutely. We're not trying to prescribe to you all a single way of going about and addressing these performance standards.
I'm just trying to get my Pac-12 boundary to load up, and then I'll be ready to go. Okay, so this next design example is for a roadway widening project. We selected Monroe County, and it's kind of hard to see because of the there's several layers on here, but I'm going to turn off a couple of them. And hopefully it will pick up. But there's basically, you've got an OFW situation. You have some waters not attaining standards also in the area. And so in this case, we've got a case of the water quality nutrient removal requirements are going to be higher. So this is the Disclaimer again, this is reference purposes only, illustrative in nature. What I have here is a roadway widening. We're assuming that we have a 2-lane undivided roadway with adjacent ditches, and we're widening it to a 4-lane urban section with curb and gutter and a closed drainage system as shown in the above typical section. We're assuming there's a 10-foot shared use path on one side of the right-of-way and an 8-foot wide sidewalk on the opposite side for a total impervious width of 66 feet. So in the existing condition, we have a 100-foot right-of-way. In the proposed condition, we have a 200-foot right-of-way. And the primary stormwater management system is exfiltration trench and with dry retention ponds providing any additional nutrient removal as required. I'm doing this, we did this example on a roadway basin type examples so that we assumed each basin was a 1/4 mile in length. So for each 1/4 mile of roadway widening, what do we have to do for stormwater? So as we had before, it's determining which HUC you're in, HUC 12 you're in, and do you have any outstanding Florida waters? Do you have any waters not attaining standards? The blue here is OFWs. I think the roadway I assumed was here in this fairly remote area of the county, 2-lane. And but in this case, we made the assumption that the surrounding land is pasture. But I do have an OFW downstream. So when you look at your nutrient removal requirements, that's going to play into that. The total area for a 1/4 mile of 200-foot wide right-of-way is 6.06 acres. There's existing impervious area, the existing 2-lane roadway. And then the water table and receiving water bodies, water table is really high, the receiving water table is the same. So because we have an OFW downstream, we are looking at higher nutrient removal requirements. I'm going to go back to that flow chart. So is the project located within HUC 12 containing an impaired water body upstream of that impaired water body? In this case, yes. Is the impaired, or excuse me, no, we're going to say no, that there's no impairment, but we have a site located within a HUC 12 that contains an OFW and is upstream of that OFW. So it's an 80% nitrogen and 90% phosphorus reduction from the post-development load before treatment. So that's the thing is, do you have an impaired water body in your HUC 12? Are you upstream of that impaired water body? Yes or no? If it's no, then and you have an OFW, it's 80, 90. If you do not have an OFW, it's 55 and 80. So just getting familiar with this flow chart is going to be very helpful. So I have an OFW, I'm 90% reduction in phosphorus, 80% reduction in nitrogen from the existing, pre-development condition. So I'm in meteorological zone 4 with an average annual rainfall depth of 55. Let me go back to the SWRP manual. See Monroe County down here, zone 4. And down here in that area, the rainfall rate or the rainfall depth is, the average annual rainfall depth is 55 inches. Oops. Okay, so in this case, we have 2 pre-development land uses. We have the existing highway with phosphorus and nitrogen of 0.173 and 1.25 milligrams per liter respectively, and the pasture. with a phosphorus and nitrogen of 0.593 and 3.03 respectively. These are D soils. All the impervious, though, if you look at it, 2-lane typical section, it's running off the roadway into a ditch and then off to wherever. That is not directly connected impervious area. It does meet that threshold of 20 feet over pervious undisturbed soils. So we will have to calculate a weighted curve number for the entire area. So highway, the weighted curve number for the highway is 91.3. The weighted curve number for the pasture, which is obviously all pervious, is 89. And then we go back and we calculate the runoff we find the runoff coefficients for highway and pasture. So again, we have no DCIA, we have 91.3 for highway, we have 89 for pasture. Go back to Appendix N, and we go to Zone 4, no DCIA, or 0% DCIA, 89 is going to be somewhere between 0.182 and 0.266, and just above 0.266 for highway, because that 91.3 is your curve number there. So you do the weighted curve numbers, and there's your weighted curve, your runoff coefficients. Calculating your annual runoff volume for a highway. That half of that right of way was the existing highway, 55 inches a year, 0.308, 3.03 acres, 4.277 acre feet per year for the highway, and 3.458 acre feet per year for the pasture, the existing pasture. And then calculating the mass loading, annual runoff volume, acre feet per year, times your EMC values with your conversion factors. So the highway is 4.277, the EMC for phosphorus, 0.173. That yields 0.912 kilograms per year of phosphorus loading from the highway, 6.593 kilograms per year for nitrogen loading from the highway portion. For the pasture portion, your yield is 2.529 kilograms per year, and your nitrogen loading is 12.92 kilograms per year. So you want to add those two together to get your total loading for your 6-acre site. So you have a total loading of phosphorus of 3.441 and a total loading of nitrogen of 19.513. Now, in the post-development case, you have all 6 acres are now highway. So you go back to that EMC value of 0.173 and 1.25 for nitrogen off of table 9.2. Your impervious area is 2 acres. That was calculated early on when you look at the 66-foot width and with the 4 lanes, curb and gutter, sidewalks, all that impervious area. And we're assuming that all of the impervious area is directly connected. Those sidewalks were not, divided from the roadway by 20 feet of grass, 20 feet of pervious area. So all of that impervious area is considered directly connected. So 2 acres over 6.06 acres is 33% DCIA. You have 4 acres of pervious area, and your pervious CN is 80. Your non-DCIA CN, which is basically just your pervious area, is going to be 80. The runoff coefficient, we're going to go back to tape, and now you have 33% DCIA and a runoff coefficient of 80, or excuse me, a curve number of 80. So if you go 80 across on the curve number and up to about 35, you're looking, you can interpolate between 0.338 and 0.372. And that will get you your runoff coefficient in your post-development condition. 0.359 was our runoff coefficient. So now we're going to calculate our runoff volume, which is 9.971 acre feet per year. Just quick comparison, scroll back. Hope this doesn't bother anybody too much. You know, before we had about almost 8 acre feet per year, highway and pasture. So now let's look at the mass loading. Going back to using the highway and the nitrogen, or highway nitrogen and phosphorus loading EMC values, 0.173 and 1.25. So your annual mass loading for phosphorus is 2.127 kilograms, and your annual mass loading for nitrogen is 15.368 kilograms per year. Now we do that required load reduction. So for phosphorus, we needed the greater of 90% reduction or pre-post. So the pre-post, if we look at this, the pre-development loading was 3.441. The post-development loading is 2.127. So we only needed, excuse me. Yeah. So we didn't need a reduction. There's a reduction just because we're going from pasture to highway. This is a negative number here. But so obviously the 90% reduction will govern for the phosphorus. For the nitrogen, it's the same again because we have a pasture condition. You know, the pre-post is actually a negative number, but the 80% yield will be the greater of the two. I want to caution everybody about using pasture for your pre-development condition. Okay. We talked about having the existing land use at the time of application. So a week before you submit your application, putting up a fence and putting a cow on the site does not make it a pasture. And the other one we see a lot being used a lot is dry prairie. Dry prairie is not present very much in Orange and Osceola counties. There's a little bit of dry prairie area as defined. I have a reference book that defines it mostly in south of Lake Kissimmee. So it's not all going to be dry prairie. It's not going to be pasture. And if there were citrus trees there 20 years ago, it's not citrus now. So be very cautious when looking at your pre-development land use and be conservative. The things I just want to point out, things that I look at when I'm looking at pre-development land use. This is part of our we have the Quick Maps app in our website. We have the RegGeo app in our website that you may or may not, but the Quick Maps app, you can look at what is the the district land cover. You know, the district land cover is going to come up and it may say that it's agricultural. But if it says abandoned groves, okay, that doesn't mean you use citrus. What is it being for? The other thing I will look at is the natural soil landscape position. So what type of soils do you have? And our system, you know, our data may say that it's knolls, or it may say it's flatwood soils. So I'm going to say, okay, see, flatwood soils. So it's probably not dry prairie. It might be, you know, flatwood soil, you know, flatwoods. I believe there's several options for flatwoods in table 9.2. There's wet flatwoods, scrubby flatwoods, mesic flatwoods. And then the other thing I want y'all to look at is your environmental report, because your environmental report, if you know, should discuss the land use as far as the open undeveloped land. If you're not looking at that environmental report, you should be, because that will tell you, okay, I've got rangeland, I've got xeric scrub, I've got, mesic flatwoods, whatever. But look at those three look at the flux code, look at the soil landscapes, look at the environmental report to get your pre-development land use. Because if I see pasture, I can guarantee you I'm going to double check it or triple check it to make sure that's the appropriate land use. So in this case, because we said yes, it's pasture, the net improvement criteria is what's going to govern on this. The assumptions we made were, okay, I'm going to use exfiltration trench as my first BMP. Runoff comes off the road into inlets, and then exfiltration trench between the inlets. Realizing that I had a roadway basin that's a 1/4 mile long, 1,320 feet, how much exfiltration trench can I put into that? Yes, we can say, oh, we could put it down both sides of the road. That's not likely to be the case. So we're going to make the assumption that we don't want the length of exfiltration trench to exceed the length of the basin. Exfiltration trench equation that Jess had up, and that is in our volume 2. That exfiltration trench equation, you need to get a hydraulic conductivity rate that needs to be site specific. This value here, this K value here, needs to be site specific. You get that from geotechnical investigations, get some soil borings. If you get permeability, which is in inches per hour, then ask your geotechnical engineer to develop a hydraulic conductivity, which is CFS per feet squared per feet of head. The two are not, it's not just a matter of interchanging as far as units. So make sure you get the correct information for the type of retention you're doing. So in this case, your K value, we had a K value of 1.3 times 10 to the -4 CFS per feet squared per feet of head. There's our seasonal high water table. We assumed that our weir was at 6.5 inches. We have 2.5 feet of head, driving head. The trench width was 6 feet. The top of the trench was at elevation 7. The bottom of the trench was at 4 feet. So we have no saturated trench. We have a safety factor of 2. And then we're using this equation out of appendix O, I believe, to calculate how much volume the trench has and how much length we get. So in this case, we get 0.57 inches of treatment depth, and that gives us a 64% load reduction. Going back to Appendix O. And I'm going to go back to Appendix O. And we're looking at Zone 4. So I've got to, excuse me, but I'm going to scroll all the way through the zones. And then Zone 4, this is 1/2 inch of retention in Zone 4 gives us, with a non-DCIA CN of 33% and or non-DCIA CN of 80 and a DCIA percent of 33, or DCI percentage of 33%. So you get around 60% removal rate in that exfiltration trench. Okay. So this is a typical exfiltration trench. This is the right out of our Appendix O. So obviously 64% for TP and TN is not the 90 and 80 that we need. We need a secondary system. So we use that treatment train equation again. equation 9-5. So I need 90%. I'm getting 64% out of the exfiltration trench. I need 72.22% for phosphorus. And for nitrogen, I need 44.44% removal rate. So 1 inch of retention for that curve number of 80, DCIA of 33% will get me 78.48% nutrient removal. Again, I'm going to flip back to that. So 1 inch of retention in zone 4, a non-DCIA or DCIA percentage of 33. So I'm going to go down here to the 35 or to go down to 30. And I'm going to look at 80 on my curve number. That's 78.6, 78.4 for 35. So that, sorry, will, there you go. So that will provide the additional retention volume, will provide the additional nutrient removal that is to meet the criteria. So retention volume, retention depth, total area. So 1 inch over 6.06 acres is 0.505 acre feet. And we did not size a pond here. It's just determining, okay, I need a dry retention system that has 0.505 acre feet of volume. You will need to demonstrate that 0.5 acre, that volume does recover in 72 hours or less. So this is our total load reduction here of 92.25 for the phosphorus and the nitrogen because we're using retention systems for both. And then the summary, pre-development annual mass loading, post-development before treatment, how much we have to remove, what our targets are, and then demonstrating that we've met those targets for load reduction. I want to say on the retention systems, when you've got a dry retention system, again, you want that distance between the seasonal high groundwater table elevation and the bottom of your pond. You need site-specific data as far as, in this case, you would want a percolation rate, inches per hour, feet per day. And then when you're determining your peak stages in your ponds for the water quantity calculations, which are essentially the same, you'll turn off your percolation when you're determining your peak stages and discharges from your pond. But you want that percolation, do that as a slug load to show that it recovers in 72 hours or less. Okay. So just some notes. You're going to have to also include a safety factor of 2.2 in your retention volume recovery. The exfiltration trench equation includes that safety factor, but for the dry retention pond, you're going to have to, typically you can, we would tell you to take your percolation rates and divide them by 2. Or you can show recovery in 36 hours or less if you keep your percolation rates the same. Either which way, you've got that safety factor of 2 in that system, in your system. And you want site-specific percolation rates. So what we have in our design examples, we have these references. We have the Huck 12 boundary. There's a link that'll take you to that site that'll show you, there's that flow chart. Again, there's a link to take you to the DEP website to show you Appendix M, N, and O are all, and Table 9-2 are all within our SWRP, our statewide ERP handbook, which is available on the district's website. And that concludes the design example portion of this presentation. And I'll hand it back to Jess or Melissa.
All right, thanks, Patty. So now I think we're going to move into question and answers. So Jess, if you have the slide available, if you want to go ahead and put that up. So if anyone has any questions, we're happy to take them at this time. If you have questions on a specific project, we're going to ask that you do not ask them in this forum, that you direct those to your project reviewer for that project. They'll be able to best help you with any project specific questions. But if you have any general questions, we're happy to take them at this time. If you're on Zoom, you can use the raise hand feature. If you're on the phone, you can use *9 to raise your hand. We also do have a general email address set up that you can use as well if we don't have time to get to you in this session. But just be patient if you do send an email to that email address. It may take us a while to respond, depending how many emails come in. So if anyone has any questions, you may go ahead and use that raise hand feature if you'd like to ask them at this time. We're going to go ahead and start with Mike. Oh, he put his hand down. So Pedro, if you have a question, please go ahead and unmute yourself, and then you can, or I think, yep, Pedro, you're unmuted. So go ahead and ask your question, please. Pedro Martinez, you're unmuted. If you have a question, you can ask it at this time.
Can you hear me?
Yep, we can hear you.
Where can we find the links to all the, it was a really good tutorial, but it had all the links really organized properly. I didn't know if I could get a copy of those. My greatest downfall is the land uses you mentioned. You know, you said, oh, if we don't pick the correct land use, you know, we'll go back and review that. So I want to make sure that I'm starting with the correct background information or basic information.
So the design examples we went over today are going to be made available on our website. So you will have access to the design examples that we went over today.
Do you know where on the website?
We will communicate that to all of the attendees once we conclude our final session on Thursday. Presentation will be made available.
Okay, awesome. Because it had like the links, it had like quick links to like land use and the GIS. I was trying to follow it as we went through, but I had a hard time.
So some of the links, some of the coverages that Patty showed are available through our district's GIS database. We can try and make those links available to you. But generally speaking, the first place you want to look for pre-development land use is going to be your flux codes. And I think there are various sources out there for that. But we can certainly try and create a catalog of links available to the public.
Okay.
Jess, I will put up a quick link just in a moment. A quick show people on the website as soon as I can call it up.
Thanks, Patty. All right, Paul. We're going to go ahead and unmute your mic. So Paul, go ahead and ask your question, please.
Hi, everyone. Good morning. Yeah, I was wondering if there was any technical guidance regarding stormwater systems that do not have an outfall, that are entirely closed and maybe only served by exfiltration trench, and how this criteria and the requirements apply to it.
So at present, if you want to attempt to demonstrate that your site is zero discharge for the purpose of water quality, you'll need to analyze the entire period of record that is used to establish the isopleth that we saw. Again, this is an average annual year. So when we're referring to rainfall in the context of water quality performance standards, it is not tied to a specific storm event. So capturing anything, including up to the 100-year event, is not adequate to demonstrate that you are not going to discharge for the purpose of water quality. You would need to look at the data that was compiled in that 2007 report and then go through and demonstrate that for every storm in that average annual year, that you are not going to discharge from your design.
Thank you.
Jess, if you could unmute yourself, or not unmute, I'm sorry. If you could stop sharing your screen for just a moment, I'll put up this website. Thank you. Ah, sorry, I picked the wrong screen. Okay, this is our district website. If you just go to the main district website and click on select science and data and GIS, it will come up with this Quick Maps app option. And that was the one that I was showing you that had the flux. You can add in the flux codes and get the flux codes off of that, the land use and the soils data.
Patty, why don't you go ahead and walk through? Yeah.
Yeah, you're just
show
going to
folks how to
click
do
on that Quick Maps option. And then down on the bottom, you will see your map layers. For example, here's environmental resource permits. You would just click on the application environmental resource, and that will pull up all the permits, and so you have to go into the subset. Then over here on the right, there's a button to add data. And on the add data, you would type in FLUCCS, Florida Land Use Cover and Classification System. And that will pull up a variety. I want to pick a map image layer. And I don't know where that went. Okay. But that's the kind of that, you start with the Quick Maps app, and the DEP website is also a good option too. So that's a start.
Thank you, Patty. All right, so next question is going to be Joseph. We're going to go ahead and unmute your mic. You can ask your question.
Hi. I may have missed this in Patricia's first example, but is there a CN value for permeable pavement less than 98 that the district would accept? And if so, is that the same policy across all districts?
Joseph,
We assume pervious pavement is still, it's pervious pavement, yes, but we assume that the curb number is still an impervious area.
With a CN value of 98.
Yes.
Okay, thank you.
All right, next question is going to be Matthew. We're going to go ahead and unmute your mic. All right.
Yes. Thank you. So my question is regarding to the existing pre-land use. If we have a development that had a previous permit, but additional impervious was added, and did not get any permit like modifications or anything for it. When we start looking at using the earlier slide says use current aerials today. So are we going to make the assessment and the pre-loading on all that existing impervious is in the pre, or are we going to, like traditionally we would go back and look at the historic aerials, like what was there before that, before they constructed something that wasn't permitted. So I'm just asking, what's the policy for that situation if you have a project where anything was built and didn't obtain a permit under the old rules? How do we approach that with the new rules?
So the definition of pre-development does have the phrase legally in existence. So if that area that you're referring to was not permitted, you would have to go back before that and consider a less impervious condition as your pre-development.
Okay, so in that instance, we would use the historic aerials back before or the old permit information prior.
Correct.
Okay. All right. Thank you.
All right, next question is Renee. We're going to go ahead and unmute your mic. Can we please unmute Renee's mic? Devon, can you unmute that mic for us, please?
They have to unmute the mic for themselves. I can't unmute it.
Okay.
I can only
Renee.
enable them to unmute the mic.
Okay. Renee, can you unmute your mic, please? Renee Diaz? All right, we're going to move on to Robert Moon. You can go ahead and unmute your mic, please. All right, you can ask your question.
Can you hear me?
Yeah.
Good morning. Yeah, so when using a biofiltration downstream of a pond or a holding mechanism, there's a certain amount of volume going through the biofiltration that you use to calculate your treatment depth. Are you looking for that volume to be the static volume, like under the weir, or is it the total routed volume through the H&H model?
The total routed volume.
And there's no offline, online considerations with that. Just whatever we show being routed through the models, what we can count through the media, and then for treatment depth.
Correct.
Perfect. Thank you.
All right, we're going to try Arnaldo, please. If you can go ahead and unmute your mic, please.
Yes, can you hear me?
Yep, we can.
Yes, no, just to know if you have a PDF file for this presentation.
Yes, we have a PDF for the presentation and it will be posted on our website, and we will be sending out a link to where it will be posted.
Okay, thank you so much.
You're welcome. All right, next up, we're going to have Giovanna. If you could please go ahead and unmute your mic.
Hi, I had a question about the commercial and industrial with the 20% load reduction and a retention BMP, also the greater than 40% impervious area. If there were a situation where it was both of those, so commercial and industrial plus the greater than 40% impervious area, would 20% or 40% of the load reduction have to come from a retention BMP?
20%.
20%. Okay, thank you.
All right, Sue, if you could please go ahead and unmute your mic.
Good afternoon. I just had a question on, I know this is off topic on water quality standards. I just wanted to make sure that all of the rule changes are not going to impact the 62-330 exempt activities, or will there be changes for exempt activities as well?
Exempt activities are required to meet the water quality criteria that are in place. So if you'll allow me, at the, I believe the 62.330.050 discusses the kind of high level requirements of an exempt project with regard to flood impacts and water quality treatment. So just because a project is exempt, unless there's something very specific in the particular exemption, the concept of having to provide flood protection and water quality treatment remains.
Thanks.
All right, next up we have Mohammed. You can go ahead and unmute your mic.
Yes, hello, can you hear me?
Yep, you're unmuted. Go ahead.
Just a question about the exfiltration trench. When the exfiltration pipe is lower than the seasonal high water, does it affect the water quality credit?
No, it would not. The exfiltration trench formula looks at saturated, unsaturated trench depths, which are not a function of the invert of the pipe, just a function of the seasonal high water table.
Okay.
All right, Shihab, we can go ahead and unmute your mic, please.
Okay, thank you, everyone. My question is, it seems like in some instances we will have to have BMPs in series to reach the target removal percentage. And on sites where you're restricted, in South Florida here, for example, we're very restricted sometimes with real estate or what we can do. And let's assume we have a site with two different drainage areas, and you need to provide BMPs in series to achieve your target removal rates. But you don't have the real estate to do so. Is there a situation where you can overcompensate on one drainage area or for BMP removal or for nutrient load removal than the other one to make up for it?
Yes, in the circumstance where your ultimate outfall is to the same water body. So what we are looking at is that the load being discharged to the receiving body meets the criteria. A very gross example is you have 100 pounds coming off one basin, 200 pounds coming off the other, and you need to only be discharging 100 pounds to the receiving body. You can remove that 200-pound difference anywhere that you want.
All right,
So
thank
in
you.
one of your bases, you could discharge, you could reduce more than its strict percentage, because what we're looking at is that tailwater And we're looking from the tailwater upstream, not always from the project downstream.
Okay, next question is going to be Kevin. Kevin, you can go ahead and unmute your mic.
Hi, can you hear me?
We can.
All right, got a quick question. So I know the method of recovery for the retention ponds is going to be obviously through groundwater infiltration, and we've been asked to do groundwater mounding. We've run into a couple of projects where we've gotten some site geo done, and the infiltration rates of the existing soils were really poor and it wasn't really feasible to recover the soil within, or the water within the 72 hours. What is the district's approach on soil remediation in the case where, geo testing was conducted and the soils were, poor enough to not allow for proper recovery?
So if you're going to design a system that allows for the remediation, and I'm assuming by remediation you mean like the wholesale removal of the poorly drained soils and importing in soil that has a better infiltration rate.
Sure.
In that circumstance, we're going to take a very long look at the specifications. It won't simply be a matter of showing on a set of plans or a set of calculations, remove X cubic feet or acre feet of this type of soil and replace with another. We're going to want to understand where you're sourcing that material from. We're going to need to see, if not upfront, then as a post-permit compliance deliverable, evidence that that material is being delivered and installed, and some kind of mechanism for the long-time assurance that that percolation rate is going to remain. And these projects are in perpetuity. The O&M requirements are also in perpetuity. So the reasonable assurance will be of a greater standard if you propose to import in more well-draining soil and essentially change your hydrologic soil group or your curve number in that mechanism.
Okay, yeah, sounds good. It sounds like it's going to be kind of a project by project thing.
And it is something that you can do. It's just the effort to achieve it is going to be greater than what you would normally have to do if you're using in situ soils.
Understood. Thank you.
All right. Thank you. Gabrielle, you can go ahead and unmute yourself.
Good morning. Can you hear me?
We can.
Right. Thank you very much. I just want to circle back a little bit to a question that was asked in the beginning regarding the projects with zero discharge. And if I understood correctly, so for water quality purposes, I guess it's not based on the 100-year, 25-year, or 10-year storms. Is based on the annual loading for the specific area where we are. Is that correct? And also you mentioned something about a study from 2007. Can you please repeat? I guess my question is, how is there guidance on how to prove if our site does not what's it called, discharge, given that we're not, the way that we're looking at water quality is not the same as water quantity. I don't know if you understand my question. Let me know, maybe I can explain it better.
I think I do. Let me give it a shot at answering it and we'll see. So your first question, you are correct. It is not based on a single storm event. The second part, the reference I made was to a report from DEP authored by Harvey Harper. I don't have the report at hand, but the title, something to the effect of the evaluation of stormwater criteria in the state of Florida. It is where Dr. Harper lays out the various methodologies for calculating these runoff volumes over the course of a year, as well as determining the efficiencies of the various kinds of BMPs. In it, he provides all of the rainfall data that he used to establish those rainfall maps that we showed. And so what you would need to do in that circumstance is look at that data and find the rainfall gauges that would be closest to your site, come up with the map, if you will, of when it rained in that average annual period and how much it rained. And then you would need to do an analysis that demonstrates that under those conditions, your site does not discharge.
Okay, understood.
All right, next up we have Mike. We're going to go ahead and you can unmute your mic.
Okay, can you hear me?
We can.
Okay, great. I have a whole bunch of questions, and I know we've been on here for a long time. I just need some clarification on several things. On a rain event now, are we not to use NOAA criteria? We're just supposed to use the criteria on the zone maps now?
For the purpose of water quality. Water quantity is a different animal. So using the water management district's isohydral maps for particular storm events or NOAA data for a specific storm event is still how you need to conduct your H&H analysis. But your water quality is based on those zones and the corresponding isopleth.
Okay, and for NOAA, what event, or are we using one event all throughout Florida for stormwater calculations?
Not for water quantity, no. Each district still has its own volume 2. Those volume 2s dictate design storms, storms to calculate roadway crown elevations, storms to calculate perimeter berm elevations, finished floor elevations, and any other criteria. But those are all specific to each of the 5 water management districts.
Where do we find those?
Each district has its own volume 2. They're available through their respective websites.
Okay, and then as far as drainage coefficients go, same thing on quantity, or can we use empirical values?
For empirical values, well, you may need, if you're talking about site-specific values, you'd have to demonstrate why you're using those. But for H&H, you're still going to follow the very classic methods that are available. In our district, we shy away from the rational method, for instance, and what we're looking for is more of a TR55 based approach to runoff, unit hydrographs to establish the distribution, and then routing those storm events through your water management system to determine what the resulting discharges and peak stages will be.
You mentioned the ER. What was the ER? You said not to use the rational method?
No, we do not. We find that the rational method over predicts and doesn't take into account things like storage. So it is the curve number method that developed by the NRCS is the method of runoff calculation.
And where do you get that?
TR55 is, I'm sorry to jump in, but TR55, Technical Release 55, National Resource Conservation Service. That's out of the federal, it's a federal website.
For even small acreages, like less than 10 acres?
Yes.
Wow. Okay, and the next question, if we have a new site that's new construction, is it acceptable to bring in soil group A or B into Florida and build up enough that you can have all of the storm water absorbed within 72 hours?
Yes, but as I discussed with the other gentleman's question, you'd have to provide a great deal of documentation both during the permit review process and after the permit was issued to ensure that those assumptions are actually going to be realized in the field.
Okay, do you have for each of the soil classification groups, do you have effective storage coefficients available for saturated and unsaturated conditions?
We would rely, again, based on TR 55. We also have specific to our district, a table that classifies soil groups into 3 macro categories: coastal, depressional, and flatwoods. And then as a function of the depth of water table describes what the soil storage is for each of those.
And where do I get that?
That's also available in our ERP Applicants Handbook, Volume 2, which is available through our website.
Volume 2. And does it also have the average vertical and horizontal connectivity values?
No, those are site-specific values that need to be determined through geotech exploration.
Oh, wow. Do y'all offer any assistance with soil analysis?
We do not.
You have recommended that aren't high dollar values to cost it?
So do we have recommended high dollar values? I'm sorry, I don't.
I'm sorry. Costs that are in line with reasonable geotech services throughout Florida. I mean, they're all over.
We do not.
All right. Can I keep going, please?
Well, actually, if we could, if we could bring this one to close, and maybe get you in at the end. I think we have quite a few folks with their hands raised.
Well, is it possible to get your contact information and call?
That website, we put an email address up in the last slide. I'll bring it back up, and you can direct your questions to that.
Okay, I'm going to hang on for a few more minutes if you can come back to me.
We will do what we can.
Thank you. All right, next up is Michael. Go ahead and unmute yourself, please.
Hi, can you hear me okay?
We can.
All right. First question, I just have 2. One is, I assume that the new water quality rules that we're talking about here are overriding the previous water quality rules with respect to each district, right? So like there's no more half-inch over the basin for dry retention. We're strictly going off the nutrient removal criteria.
The general answer is yes, but as I mentioned very early on, there are still a number of grandfathering provisions in effect. So there are very specific cases where projects may still be designing by and evaluated under the volumetric criteria.
Right, thanks. But for new projects, it is by and large overriding those previous criteria. Okay.
For new projects that have that do not meet any other grandfathering criteria, yes, it is the new criteria and they overwrite. Okay.
And last question is, I want to clarify the exemption criteria for redevelopment area. The way the code read, it said sites under 1 acre, I believe, and is so by site. So if I have a parcel that's 5 acres, but the only actual development on that parcel is 1 acre, would that apply? I'm looking specifically at the area criteria there. Is it project area, I guess I'm asking, or are you viewing that as parcel area?
It is project area. But we will, if we see a 1 acre cutout within a larger parcel, we're going to want to understand what is going to go on with the rest of that parcel in the future. This exemption and other kinds of things like it are not intended to be quilted into larger plans of common development. Understood. So for instance, in your example, we would not seek to give 5 different exemptions.
Understood.
Of 1 acre apiece for a 5 acre total parcel.
Yeah. So I mean, if I have an owner who has 5 acres on a property where it's 4 acres undevelopable, either floodplain or wooded, whatever, they don't want to touch it, and they just want to build a 1 acre project at the corner and be done. That would particularly apply to that.
Yes, with
As
all
long
of
as
the
there's not a
criteria being met.
master plan that, I understand what you're talking about there. You don't want them to come in and do 5 exemptions.
Correct.
Okay, thank you.
All right, next up we have Mark. Mark, please go ahead and unmute yourself.
Good morning.
Good morning.
Quick question. Previously you mentioned dry pretreatment systems now requiring a 20% load reduction. I just wanted to clarify, that's just for newest systems. So any of the existing master systems can still use the half-inch dry pretreatment?
If it has a valid permit over it, then yes, but if that permit is expired, if you're coming in for a new project, even though it's part of a larger plan of development, we'll have to look more closely at if any grandfathering criteria apply, but if they do not, that project will be held to the new standard of 20% of the load reduction in a retention system.
All right, sounds good. Thank you.
All right, next up we have Spencer. Spencer, please go ahead and unmute yourself. Spencer Morton, please go ahead and unmute yourself. All right.
Sorry, I forgot that I'm registered under my coworker's name.
That's okay.
I just wanted to verify that the webinar on Thursday is a repeat of this.
It is. The only difference is going to be we'll be going over different design examples, but besides that, it's the same webinar. It's going to be the same presentation.
Okay, thank you very much.
You're welcome. All right, next up we have Robert Moon. Please go ahead and unmute yourself.
Yeah, it was just a follow-up question regarding the hydrology H&H model of the water through a filter. Would that be the mean annual event we need to demonstrate that volume?
Yes, that is the basis of the water quality performance standards.
Perfect, thank you.
All right, next up we have Brian. Brian, please go ahead and unmute yourself.
Hello. Can you hear me?
We can, go ahead.
Okay. I guess I got a couple questions. For the PAV for like a wet detention, is there a way that's been calculated now, or is that no longer a requirement?
And I'm sorry, I'm not, what's PAV?
Pollution abatement volume.
So no, that is not being calculated any longer. That was that 1 inch over the site or 2.5 times the percentage impervious.
So then wet detention, there would be no orifice. It would just be a weir or.
No, we still have, okay, so I'll be more clear. I'm sorry. We do still have discharge restrictions. And that may still yield an orifice being discharged, being used for discharge, and we have limited the rate for what you're calling PAV, that distance to be still a 1/2 inch in 24 hours, or 13.5 CFS per square mile.
Okay, gotcha. And then BMP trains, that's perfectly acceptable to use. I know you have the charts that kind of correlate to what BMP trains has built into their calculations. Would we have to specifically use the charts that you guys showed in your appendices, or is it okay to use BMP trains?
BMP trains is perfectly acceptable as a model to use. Version 4.3.5 is the current one that's being accepted around the state. It's now out on the DOT's website. One thing to note, the last time I looked at that version, it did not have the same EMC values that are in the rule. So you will need to use the user-defined values and make sure they are consistent with what is in rule. The runoff coefficient calculator is consistent with the tables. So that part of it can be used once you put in the correct project areas, curve numbers, and DCIA percentages.
Okay. And then I got an area that has a very high groundwater table, and we're looking to do industrial in that area. So we would have to bring in fill, build it up, and then treat 20% of the removal, I guess, for with retention. So for percolation, how would that be determined? How would you guys want that to be determined if we don't have would it be based on the existing like ground conditions, or would you be able to base it on the fill that would be placed in the area, or
It would be based on the fill placed in the area, but you'd have to give us, a lot of very specific data about that fill
okay.
to justify the assumptions you use in your analysis of recovery.
Would any of that have to be specific through a geotech?
That would be the typical way that, yes, we're not going to accept, large scale, like looking at the soil survey, for instance, and you coming up with a percolation rate or an infiltration rate based on a soil survey. We're not going to accept that. It needs to be site specific.
Okay. And then underground retention. You guys don't have any issues with that, correct?
No, we do not.
Okay. And then if that is placed on existing ground that has good percolation rates, then those percolation rates are okay to use for the
Yes.
underground retention. Okay. And then there's a like a focal point product on the market. Do you guys allow that product to be used as a BMP?
Right now, we are only using the BMPs that are listed in that table. DEP does on occasion review different product types, and is working on a procedure by which they can evaluate those and assign them a removal percentage.
Okay. Do you know how far out that would be?
I do not.
Okay. And then Bold and Gold, do you guys still allow bioabsorbent?
Yes, it is a
Okay.
BMP that is addressed in applicant's handbook volume 1.
Okay. Okay. That's all I had.
All right, next up we have Eric. Eric, if you can go ahead and unmute yourself.
Hello?
Yep.
I just wanted to find out if the flow chart you covered at the beginning of your presentation is only for the presentation, or is that posted somewhere online?
It's posted on FDEP's website.
Okay, where would you find that?
It's
There
do you want to go ahead, Jess? I think you're sharing your screen.
Yeah, I'll see if I can bring this up. So there is a link in the presentation that will be available to you once we conclude our final presentation. But in the interim, if you Google DEP ERP Stormwater Resource Center, you'll come to what I've got up on the screen. Towards the bottom of that.
Hey, Jess, you're still got the presentation up.
Oh, I apologize. Okay, so ERP Stormwater Resource Center through DEP's website. Towards the bottom of that, they have a few links for various flow charts. One is the grandfathering flow chart I mentioned early on. The other, the one that you're asking about, is this performance criteria flow chart.
You're not sharing. There you go.
All right.
Now we're there.
So now here's where you get to that flow chart. It's a PDF. So this is something that DEP has come up with for the entire state.
Great, thank you.
You're welcome.
All right, Wes, you can go ahead and unmute yourself. Wes Kane, if you have a question, you can unmute.
not sure if I'm showing up as Wes. I guess I am. It's actually Mark from the same office. I had one question regarding clarification on that half-inch rule for the 24-hour discharge. It sounds like that's still in effect, but as far as we can tell with the new rules, you don't still consider the half-inch discharge over a 24-hour period.
It is still in effect.
Where is that under in the new code?
Believe it's under an applicant's handbook 2. Bear with me.
It's an applicant's handbook 2, section 3.1.
Right, and there should be a reference to 13.5 CSM as the rate at which that water, 13.5 CSM, is equivalent to a half-inch over an acre, or over the site.
Okay, and you said that was in section 3.1?
Actually, it's 3.1 is the one that just says historic, but it's 5.1A, which discusses the maximum discharge for bleed down systems.
And then that's in volume 2, you said, right?
Correct.
Yes.
Volume 2.
Okay. Correct. It says the maximum discharge is 13.5 CSM, minimum cross-section, no area, pretty much similar stuff as far as control structure geometry goes. But where does it discuss bleed down within a 24-hour period?
That's what 13.5 CFS per square mile is. That equates to a half-inch in 24 hours.
Sorry, Jesse, I don't know if it's just me. It's a little hard to hear you sometimes. Could you repeat that?
13.5 CFS per square mile equates to a half-inch in 24 hours.
Okay.
So if you design a bleeder that it only passes 13.5 CSM, then that is comparable to what was in the rule to begin with.
Okay, so do you guys still want to see like a highlighted analysis of the bleed down volumes showing that we're not exceeding anything within a 24-hour period?
Yes.
Okay, well, that clarifies things for me. Thank you.
All right, next up we have Paul. Paul, you can unmute yourself.
Hi again. Can you hear me?
We can.
I have a site that was exempted prior to the new rules, and I know we had a slide up for the exemption. I was wondering if the new rules might change any of that as it relates to prior exemptions. If we can rely on, not necessarily rely, but is it a safe assumption to assume that the conditions that were allowed a site to be exempted before the new rules might still apply today?
So any exemption you've already received is still in effect.
Okay.
All right. Next up, we have Brent. Brent, you can go ahead and unmute yourself.
Hey, good afternoon. Can you hear me?
We can.
Morning, I guess. If your site is located within a BMAP that has designated that dry detention can remove 10% of the nutrients, is that acceptable?
And you're being very, very precise in your definition of detention. Meaning you've got a leader at the bottom or below.
I can only assume from looking at the BMAP that that's what that is inferring, but I would assume that to be the traditional dry detention method at a foot below control.
Okay.
Or excuse me, with the pond a foot above control.
These current water quality criteria, both in volume 1 and volume 2, no longer recognize dry detention as a means of removing load. So the short answer would be no.
Okay.
All right, next up we have Robert. Robert, you can unmute yourself.
Yeah, thanks for the opportunity to ask more questions. Could you please just kind of talk on the grandfathering exemptions for properties within planned unit developments or master plans or similar entitlements? If it's within a PUD and if a pond is constructed or not, are we exempt, or does it have to be a PUD with an existing system?
So if you've got a project that received PUD approval before January 1 of 2024, then, you know what, before I guess on that, let me open that criteria. So you're referring to a project that is within a PUD. If that PUD was approved at the local level prior to, I'm sorry, I'm getting to it.
It's January 1st of 2024.
All right, January 1st of 2024, then that project is subject to the volumetric criteria. It is one of those grandfathering provisions that extends the use of the previous criteria.
Okay. And then what if you had, let's say it was a straight zone commercial property that had 4 lots and a master pond, and there's 1 lot left that hasn't been constructed, but it's not a PUD, but we are, was going to a pond designed for, say, 80% impervious under volumetric. Are we exempt, or do you have to now do nutrient loading for that last parcel?
You'd have to do nutrient loading for that parcel because it is not grandfathered and presumably coming in after the effective date of all these rules.
Okay, so the key is that it has to have the planned unit development entitlements, because they also have the word master plans in the code. I wasn't sure how that's interpreted.
And that will have to be determined on a case-by-case basis because every, local government has a slightly different definition, and our staff at the Water Management District is by no means an expert on all of those. So it is possible that what the hypothetical you're describing would lead to a determination that that last parcel is grandfathered, but by and large, the criteria with respect to dates speak for themselves. And then we'll have to look more closely at the details of what the local government approved versus what you're submitting now in an application.
Gotcha. So the term master plan, you're looking for that more as an entitlement term, not just, hey, it's a master plan.
We're looking to see what is the equivalent term for the local government that granted the approval.
Gotcha.
All right, Alejandro, you can go ahead and unmute yourself.
Good morning, guys. I wanted to ask on, you said that the rainfall volumes and the yearly volumetric calculations were based off of that evaluation of stormwater design criteria within South Florida report from Harper. One thing I wanted to ask with regards to that, I noticed that in that report, for the most part, if you look at the percentage of annual rainfall events occurring in a selected event interval, there's a table 3-2. It looks like more than 99% of the rainfall events fall under, I would say about 4 to 4.5, 3.5 to 4 inches, something like that. And then if there's also another table where, like, for example, in the Miami area, it'll show you that rainfall station for the period of record from 1942 to 2005, that about 98% of the rainfall events fall under 9 inches of rainfall. When we're talking about annual discharge offside and trying to achieve those metrics of 90 or even further north of that, as per your example, wouldn't that looking at these tables, wouldn't it tell us that if we're covering a 9-inch rainfall for, let's say, a mean rainfall duration of 22 hours, as it is in this table, you could technically be achieving 98% pollutant removal for most of your design events? Or even, let's say, if you want to consider it a self-contained site containing up to and above, let's say the 25-year, even the 100-year event where rainfall amounts are in excess of the 10 inches or 15 inches or whatever, wouldn't that be showing or proving to the district that we'd be meeting those metrics for pollutant removal?
That would be part of the analysis you would provide. The kind of analysis that we would expect to discuss zero discharge would be a continuous simulation analysis, not a single storm. So you would run that entire year of that period of record, the average year from that period of record through your system, but it would not be focused on a single storm event.
But then you're running a bunch of years of events where all the events are less than whatever that peak stage whatever that peak rainfall event will be. So wouldn't it be more efficient to just run the day where that peak rainfall event occurred?
Perhaps, but I want to make sure that there is an apples to apples comparison. So if you take the rainfall record from that report for that state, for that gauge, then you have a direct one-to-one comparison.
So then it would be, so we would be running a bunch of 1, 2, and 3 inch rainfall events to get to that peak rainfall event, and then go back to all the 1, 2, whatever inch rainfall events, and the district would be okay with that being the water quality calculation for that property.
We'd have to look at the analysis, but in effect, if you've captured, I'm going to make up a total for the purpose of the example. If you run a year's worth of rainfall and you get to a cumulative rainfall of 60 inches, because that's what the isopleth says that you've got, and you've accounted for every storm that leads to that cumulative, and you demonstrate that you don't discharge at any point in time, then you have provided analysis in the context of the water quality criteria.
So that would suffice for a self-contained system, but technically, based off what you're saying, that would also account for the general, like how much pollutant loading we're discharging off-site in total, given the analysis in that 2007 report, right?
I'm not sure I understand your question.
The report is based off of statistical data for a 60-year time period. It's getting on peak rainfall amount or whatever it is for the whole study period. But if we were to run that whole entire data set and show zero discharge or just a small percentage of discharge off-site, wouldn't that be the water quality calculation for that site based off all this whole entire data set?
So not a small portion. It would be zero discharge. And but at that point in time, you have demonstrated you are not discharging within the context of water quality to any off-site water body. Then you've got you've made the case that you are a zero discharge site.
Okay, so again, running the entire data set would allow us to prove that the site can retain everything on site?
Yes.
Okay, thank you very much.
All right, next up we have Arnaldo. You can go ahead and unmute yourself.
Yes, this is just a general question. Usually we are in Miami, Florida. Basically what we do mostly is drainage improvements and roadway improvements in many streets here in Miami-Dade County. Usually our process for permitting is just to submit a drainage report where we just show that we certify the water quantity, for the storm for usually 5 years, 24 hours. These water quality metrics, how do we have to be involved in those water quality metrics that you're doing now? You are showing now?
To qualify to receive an environmental resource permit, yes.
So we have to go through we have to make a calculation for how you're showing in the exposition today, the same way, included in the drainage report?
Yes, you will have to work through, something similar to that, those design examples that we presented.
Okay. Okay, no problem.
All right, next up we have Amanda. Amanda, you can go ahead and unmute yourself.
Good afternoon, thank you. Yes, I just had a question about how this kind of all folds into the volume 2, section 1.2 for the district specific thresholds. The Paren D reads that the system can't be located in natural water bodies, wetlands, or waters, outstanding Florida waters. Does the district specific threshold still apply for works wholly in uplands if you are upstream and you have an offsite discharge?
Yes, but remember that all that criteria is whether you need an ERP.
So if we can prove it with the calc and meet the threshold, we don't have to formally apply, but we still have to work through the calculation.
You'll have to work through whatever, so that criteria is only specific to Miami-Dade County. So you'll have to work through whatever Miami-Dade DERM requires of you. If you meet those criteria, you do not need to seek an ERP from the Water Management District.
Okay, next up we have Carlos. Carlos, you can unmute.
Good morning, everyone. I got a couple of questions. Drainage wells, are discharges to drainage wells supposed to be after meeting water quality? Because there's a practice to discharge roof water directly into drainage wells. So if you could speak about that, that's my first question. I'll let you answer that, and then I'll have the other one.
So Carlos, in the Water Management District, we have required water quality treatment for the entire project before discharge through a drainage well, and that has not changed.
Okay, so the second question I have is usually in the volumetric calculations, so that's going to be in effect until December 28, the discharge starts once you meet that volumetric water quality. Can you speak about how the discharge will occur with the new calculations, or what will set the criteria for that discharge?
That goes back to that section that we mentioned earlier under Part 5 that limits discharge through a bleeder to 13.5 CFS per square mile.
Yeah, but that discharge is like from your bleeder elevation. I mean, from your weir elevation to the weir elevation. And but what sets the elevation for the weir discharge?
The head that will create that 13.5.
Okay.
And then at that point, the design of the weir is based on allowable discharge criteria. That's
okay, so let me rephrase it. So I know how to, like, okay, we have a weir and then you have an orifice discharge. You calculate the half inch with that head. But what I'm asking is what criteria sets the elevation of the weir at which you can discharge from the side during the storm? So at the beginning of the storm, you're supposed to hold the water on the side. In the classical or the previous calculation, you have to meet water quality volume first before you could discharge offside. What do you have to meet before you discharge water from the side?
It is whatever. So I thank you for clarifying. It is whatever elevation is necessary to provide that retention volume. So
okay.
If I design a system and my retention area is going to be a foot deep, because at a foot deep, I can provide whatever amount of retention over the site that gets me the load reduction I need. It is at that point, that elevation that I can begin to discharge. Because we are using retention in the very strictest sense. There is no discharge below that elevation.
Okay, yeah.
The only way that
was my
water
question.
can leave is to go into the ground.
Great. Thank you for clarifying that, Jesse.
I don't mean to belabor it, but we had a question earlier on about dry detention. So again, the idea of putting a bleeder at the bottom of your retention or your detention area or below, that no longer exists. That is something that was wholesale removed from our volume 2, because through the course of the rulemaking and the research that led up to it, it was found that a detention system, one at which discharge can occur at the control when you're trying to provide water quality in a dry system, is not effective.
Thank you.
All right, next up we have Jessica. Jessica, you can go ahead and unmute.
Hello. So can you hear me?
We can.
When you have a dry pond with underdrain to lower the seasonal high, would you consider that dry pond to still be a retention BMP? Even if it's like alongside a biofiltration media like Bolton Gold? Or how would you perceive that?
I think in that case, we would need to see some more specifics. At this point, I'm not able to give you an answer.
Okay. Thank you.
Jump in on that real quick, Jess.
Sure.
We
please.
don't allow under drains to reduce the seasonal high, to lower the seasonal high. That's in the rule that it's so we don't you're not allowed to draw it on the water table, basically.
So Jessica, maybe a bit of a clarification. Are you talking about a situation in which you're using an under drain in between the bottom of your pond and the seasonal high water table to encourage the recovery of the system? Or are you talking about an under drain that would be in the water table? Oh, we've lost Jessica. So what I will say is that an under drain in between the bottom of a retention area and the seasonal high water, that would be allowed, because since that under drain does not intersect the water table, you're not going to be discharging fresh water to tide. That is the overall one of the overall concepts we have in establishing a control elevation, a seasonal high water table, and making sure that it remains, as we do not want to see systems constantly discharging. But if you propose to put some mechanism of further lowering that water table from what the natural equilibrium condition is, then Patty is spot on. We do not allow that. That's why it is important to have on-site data that determines the elevation of your water table.
All right, it is almost 12, which is our cutoff time. So we're going to have time for just a couple more questions. So we're going to take a question from Benjamin and a question from Eric, and then we're going to wrap up. So one question from Benjamin. We're going to go ahead and let you unmute.
Go
ahead.
Good morning. Yeah, good morning. Can you hear me?
We can.
Perfect. Yeah, no, my question has to do with infiltration. If versus discharge. If, for example, we build a berm, a perimeter berm out of a highly permeable soil, maybe even let's say gravel, and there's water moving through that berm, is that considered infiltration or is that considered a discharge?
That would be considered a discharge. And when you're talking about in this scenario, this is a berm that is above your average site grade.
Correct,
then,
correct. Or above
yeah,
in the retention system, right? Containing the retention system. So is there a way to determine at what point it becomes a discharge through the berm versus infiltration? Again, if I'm using native soil versus some gravel versus a very permeable shell sand, which a lot of our native sand or native soil around here is, at what point does it become a discharge?
If the water can, I don't have a discharge rate to give you as a tolerance. What I can say is that, perimeter berms are intended to hold the water on site. So if you have created a berm that will allow water to move laterally at or above your average natural ground, then that is a discharge.
Okay. Okay. Thank you.
All right, and last question, Eric, if you can go ahead and unmute. Eric Fay, if you'd like to unmute.
Sorry, I thought I did. Thanks for taking another question. Total nitrogen, total phosphorus were covered in this presentation and seem to be the focus of the applicant's handbooks, but what about other impairments of an OFW like bacteria or dissolved oxygen? Do we have to address them?
Yes, you do. Any of those criteria, any of those sections where it also has that there needs to be a net improvement of the impairment, that too needs to be addressed in the design of the permit application.
And is that just based on BMP info from the manufacturer, or are there formulas somewhere in the handbooks?
I believe at present we are accepting that removal of nitrogen and phosphorus is presumed to also treat those other constituents.
Oh, okay.
And I believe you also have to submit a narrative as well, that also describes how your project will not contribute to that pollutant as well.
Okay, sounds good. Thank you.
All right, well, our time is up for today. So Jess, if you could put that slide up again that has that email address on it. So if anyone has any further questions, you can submit them to that email address. Again, if you do submit emails, it may take a while to get an answer, so please be patient. If you have project-specific questions, you can always submit those to your project reviewers, and they will be the best people to answer those questions. We do have another presentation. We're going to be going over the same information on Thursday afternoon from 1:30 to 4. It'll be the same presentation, different design examples. So if anybody wanted to join us for that, you're welcome to, but it will be the same, pretty much the same information that we'll be going over, and we'll also have a question and answer session then. So thank you to everyone for joining us this morning. We appreciate everyone's time and the questions. We hope everyone got something out of our session this morning, and have a great rest of your day.